Hello everyone, today we're gonna explain how we're gonna do this frame example or truss example using STAAD Pro. First, we have two types of input data to STAAD, which is the grid system or the coordinate system. In this video, I will use the coordinate system to define my structure elements. So we should now explain the heights, not only the distances as here. So the first point will be 0, 0, 0. So I have to define the x points and the y points, the main parts where my structure will be. So 0 is the first one, and here it's certain 0.25 from L1, which is 35. So 0.25 times 35, which is 0.875, and so on. So this will be 2 times this will be 3 times this, and this will be 4 times this. And for the y-axis, we know over here it's L2, it's direct forward. For the other joint, we're gonna put L2 plus L3, which is L2 plus L3. For the third joint, L2 plus L3 plus L4. For the fourth joint is from L2 to L5. And for the last one, it is L2 till L6. Now I have my bonds here. Now we'll go to STAAD Pro, click on New Project, space, next. Here you should choose your units, foot, kilopound, yes, finish. Now a grid system will open, and we have explained that we're gonna use the coordinate system. The first point is 0, 0, 0. We're not gonna change it. Now we'll move like this. We start taking this axis. So the first node is at 0, 20, after it is 0, 35, after it is 0, 53, and so on. So the x-axis is 0, the y-axis is 20, and the other point is 35, the other point is 53, and so on till we get here. We'll stop not doing the 59 because it will go in the x-axis also. So let's leave it till the end, and we will move and do this one. So the same thing, 20, 35, 53, but with the offset of 35. So I put the same numbers, 20, 53, 35, and 53. Over here, we'll put 35, which is my L1. And don't forget the 0 with the 35. Now I have my 4 nodes over here and over here, which are those 4 nodes. Let's go inside the frame. The first point will be 59 with 8.75. So I have 8.75 with 59. This point. Now, the other one is 53 with 8.75. So 8.75 with 35, which is over here. Now we'll move inside 53 with 17.5 and 53 with 26.5 and 53 with 35. So I have 53 here also with 17.5. I have 53 with 26.25. And now I have my base here. Let's go up. I want this point, which is 59 with 26.25. 59, 26.25. Now the last point is 65 with 17.5. Now I have my frame nodes on those. Let's start going inside the. After drawing the nodes, we click on add the beam and we start drawing our beams. Just make sure that you click between all nodes. So if, for example, you did that, this will be considered a whole section beam. And those are 3 beams. So make sure that you provide each 2 nodes with 1 beam. Now after finished drawing our beams, we will go to the property. So we'll start selecting the properties of those beams. I will click on top, keep on press on control and select both of those. Click on section database. I'll select any random small database. So these sections will not be considered as a final design. It will just be for computing values. Click on this, we click on steel and assign, then close. Now those are for the beams, and for the columns, I will choose an L section, not a W1. So click on section database, go to angles, and you have those three. Uh, and those three choices, I'll choose the single section and click on the smallest one and assign, then close. Now I have assigned the different sections, and I go then to the specific that you tell it what are the type of beams you have. So I select on the top ones, and I will click on commands, member specifications, then assign them as trusses. Click on and yes. So now I have them as trusses assigned. I'll go to support, then I create a new support, which is the bend. I click on add, then I see it over here. Click on assign. Yes, I'll have the nodes here. Go to load definitions. Now I'll start defining my loads. First, the WL1, WL2, WD1, WD2, and the combination at the end. So I'll start by the WL1. How I added these forces? Click on load cases details, click on add, live load, WL1, then click on add, then remove it and put WL2, click on add, and so on till you reach those four. Now I click on WL1, click on add, and member load, uniform force. So now those values should be obtained from my values over here. For the W1 live, it's 710. It's pound per foot. So, and here is kept. So I'll divide by 1000. This be 0.71. I have to know that this force is considered as upward because they are positive, so I have to put the minus, and y local to be on the side of the beam, not going down, but going down on the beam itself. Now you'll see what I mean. Click on add and close. You'll see a new force appears over here, and the WL2. Click on add. The WL2 here is 11. So go to member load uniform force, put minus 11, y local, and add, then close. The WD1 is 510 pounds for me, so it's minus 51, y local, add and close. And for the last one, I have it as 7 kept, so I put it as minus 7 and y local. Now I have assigned the values. I will put them on the drawing or on the design. So I will choose this option, click on assign. The W1s will be up and the W2s will be down. So I have WL1 here, I'll put it up and go to WD1, put it up. I will go to WL2, put it here and here. Then I'll go to WD2, put it here and here. Now I have assigned the loads. I have now to include something called load combination. I click again on the load cases details, add, then go to define combinations. Now I have to know that the live load will be factorized by 1.6 and the dead load will be 1.6, the factorized value. Now assign all of them, put them on the side. The load case one is live, then dead. So when I put them over here, the live factors are 1.6 and the dead factors are 1.2. And click on add, then close. You see a new combination appeared over here. So this one will be used for the design. After finishing the road and the finishings, we'll go to the materials, click on steel and edit it. Now those values will be obtained also from my values over here. The provided values are KSI and the needed values here are kib per feet square. So I will go to any Google software and click convert the 50 KSI to 72040 pound per feet square. I will copy this value and put it here. Now the obtained value is pound and here it's kept. So I have to remove 3 zeros from it. And my FU is 65. I will take this value and paste it over here. Now those values for the steel. Click on OK. And don't click assign because we have already assigned those sections as W and L sections and W and L sections are already steel. So don't click on assign, it's already assigned as steel sections. After finishing all of this, we will start doing the analysis. Click on save. Then you will see there is no errors. So go to processing mode. However, if you received an error that says the above line is not working well, so what you have to do only is to go to this part, analysis and print, then click on OK, all, then click on add and close it. This command enforce the STAAD to do the analysis. That do that step if you received the error. If you didn't, just go back to analysis and here's the deflection shapes. This is the most deflected shape, so click on control and go back. Now the most one I will care about is WL1, WL2, WD1, W2, but I will keep on computing everything from the combination load. So click on combination and we click on control, then roll inside and roll outside. You will see the friction shape increase and decrease. It's a scale only. So now I want to compute the values for everything. Choose results, remove the section displacement, click on result, put the bending moment. You will see the bending moment diagram appears and you will see over here that the moment transfer from the beam to the column over here. So I want to prevent that because it will be hard to be calculated. So I'll go back to modeling, double click on each beam and go to geometry, click on change release at start, make it MZ, then yes, to MZ and add, then close. Then go to the second beam and do exact same thing. Choose MZ to the end and to the start, then click OK. Now those hinges mean that the moments will stay inside those beams and not be transferred to the columns. Run the analysis, save, and go to processing, then done. I want only to study. I will remove those outside because I only want to study the combination. Apply, then OK, and you will see the friction shape is not waved as before because the moments stayed inside. Now go again to results, move the section displacement, go to bending moment, and you will see the moment here. Now, what are the values of those moments? So you can take a screenshot of the model with the values, go to view value, beam results, and here you can choose. If you select ends on it, you will see moments at the end. If you move it, put the maximum, you will see the maximum moment on each section. Now you see scientific values over here 3.98 e to the power of 3. So to remove that, if you want to change the scientific numbers, you just go to view options, then go to force or section units. You have the force units. The moments here can show only 3 decimals. That's why it's 3.98. So I'm gonna increase the moments. I'm gonna increase the force. Apply and OK. You will see it will appear normally. Now those values can be changed. For example, I want the shear. The shear will not appear. It will say that you have to open the graph of shear. So this is for everything, even for the Excel and the displacement. So to view the values, you have first to open that graph for that value. And that's it for the drawings. But how you can obtain the values? So you just go here, click right click and other tables. Once you click other tables, you will see everything that you need for your design and your load values, section properties, materials, supports, not supports, and everything. So, for example, let's just say that I want the beam and displacements, then okay. You will see the combination of the combination. You will see the nodes. You will see where is it's located and the resultant inches of displacement. This is for example, and you can do this for everything. Just choose summary, and here is the max and the minimum displacements. Close it. Now, we have already calculated everything, but we have to design this members so they can stand this is displacements and these moments. How we do that? We go back to modeling, we go down there to design. Now, I will assign all the members and click on define parameters. Then those are parameters that you can change in terms of your stiffness, your values, your kx, ky, any factor you want the program to design on. So I'll keep it on random. I'll go to the current code and change it to LR of D, which is I'm considering. Now go to select parameters. Here you would choose you will remove any parameter that you don't want to include inside, but I will include all of them. Then click last on the command. Now, here we're gonna choose what we need. Is it a group design? Is it a fixed group? What are the property specifications? And so on. So I'll click on select optimized. So I will enforce the stat to give me the lightest section that gonna carry or be safe in those designs. I click on assign, then close. I'll go again analysis and run the analysis, then save, then yes. Now activate. Now we'll go to view output file. Then click on done. You will see here some warnings that there's a stiffness. Just ignore those. It's fine. If there is no error, it's fine. So let's go to the results. You'll see here a section called steel design. Click on the steel design and go down. You will see here the STAAD have given different values that from what we have chosen at the beginning. Those sections are the latest sections that can be in that design and be safe for everything from moments to shear and according to all of the code. You see the designs and so on. However, we want to extract those information and those sections. So how we can do that? We're gonna click on this small print and go to properties and make sure that you remove the rely on system fonts only. If you didn't remove this, the program will shut down. So click on OK then. If you want some certain type of papers, I'll choose an A4. OK, then I will choose print to file. OK, I'll put it in documents, call it test, then save. Now the program will take some time to be saved. During that, I will go to the documents where it's being saved. However, to open that folder, you have to have Acrobat Adobe Reader or any relative program. Now minimize that, go to document, test, and that modified, and this is the PRN. If you didn't open, just click on right click, open with, then choose the Acrobat Adobe. It will take some time to be opened. However, when we quit, we will save it as a PDF, not .prn. So it will not take a long time after if you want to edit something or open it again. So here's the data, here is the code of the STAAD, where is the members, what are the names of it, the loads, ultimate dead load, ultimate live load, and all the report except for the stresses or members, you have to compute them by how we have explained before. Now here is the sections that are the optimum, and by doing the trials, you have chosen everything. Now you see over here that this section have failed, this section has passed. So at the end, the STAAD will keep on calculating till it computes everything that it have passed, and those sections are the sections that you can include. So STAAD keeps on giving tries till all the sections pass the design. So it starts from the minimum till it goes to the optimized one. Now those are the data from the STAAD. We close it, and with the ask we want to save the changes, you say yes because you want it as a PDF. So save it and close it. And like this, we have finished the tutorial of STAAD, and this is the minimum requirement you should follow. However, you can go back to the required tables to be computed, which are the sections, material, support, slot cases, deflected shape, and all of those have already been explained and how to get them. By going to processing, open the other tables, you will see the materials sections and everything you will need in your design. That's it for now, and thank you for watching.